a vector. We're assuming you know nothing about vectors, which may or may not be an accurate assumption, but we'll start from the ground floor. What is a vector? Well, I can refer to that great classic movie. What's the one that had the guy named Vector? Because he actually said it accurately. Yes, that's it. That's it. Remember the goofy guy that said his name was Vector that wore the jumpsuit all the time, right? Isn't it? And the little girl said, "Are you wearing pajamas?" Those are not pajamas. Anyway, sorry. Anyway. But I don't know if you remember the line. Being a math teacher, I noticed the correctness of the math line. You probably didn't pay any attention to it. But he said, "I'm vector. I am direction and magnitude." Exactly. That's what a vector is. So let's talk about that. It is direction and magnitude, meaning amount. So in other words, when we say these are two vectors, they go in a certain direction and they're a certain length. That's their magnitude. In other words, what are they not? Maybe it's helpful also to say what they're not. They're not any certain position. So in other words, if I was to take this one right here is vector u, and you see the u, it's kind of hard to see it right there. That's the u, and on the bottom one is v. They're parallel, clearly. They're also the same length. If I was to take vector u and like move it over here, but maybe that looks even a little bit longer. Maybe move it. Does that look about the same length, like right there? I'm trying to make it the same length in the same direction, just located somewhere else. That would be exactly the same vector. In other words, where they're sitting doesn't matter, but how long they are and which direction they head in. So if you turned it and say, no, I'm gonna kind of head off that direction now. Now that's a different vector. That's not vector u anymore. Even though it's the same length, same magnitude, now it's headed in a different direction, right? So as the movie got it right. I am direction and magnitude. So that's what a vector is. Wendy knows. It's like her favorite movie, right, Wendy? Despicable Me with the vector guy. We're talking vectors today. Have you seen that? All right, anyway, so that's what a vector is, direction and magnitude. So I know that might seem like, yeah, I got it. But really, it seems funny to say. You do these again in calculus, especially calculus 2. If you go up the line to calculus 2, you do a bunch of vectors in calculus. And then physics, if you keep going on, physics, you do a lot of vectors. Anyway, I remember I was in Calc 2 doing some vector thing, being confused about how they were solving the problems as I was reading the examples and trying to get through my homework, And I remember, and they were moving the vectors around. And I'm like, they can't do that. How can they move those vectors around and call it the same vector? And I was really, like a couple hours confused by that, or a couple weeks, I don't remember, just every time being confused. And then finally I went back to the original definition in the book, and then it really dawned on me. Oh yeah, a vector, it doesn't matter where it sits, it's just what direction it points in and how far it goes in that direction. That's all that matters, and that just opened up my understanding of what they were doing in the more complex settings with vectors. So I wish somebody had made it more clear to me, or they probably did, and I just wasn't listening. But anyway, so I want to make it really clear to you. A vector can go anywhere. It doesn't matter where it sits. It's just how long it is and what direction it heads in. So you can move these vectors all around, and they're the same vector. Okay, so with that general definition, let's get to some more practical things. What are these like double bar things they're putting around, see the double bar there, around the U? What does that mean? Anybody know already?
Absolute value.
It's kind of like absolute value. It's meant to remind you of that, absolutely. You're thinking the total right way. Yeah, and what does absolute value do? Let's think about absolute value. It's like the absolute value for vectors. I think that would be a good way to say it. Think about what is absolute. If I have a number like -3, what do absolute? So it's not exactly because it's double bars, not single. So it's kind of like absolute values for vectors. And think about what absolute value does. The same thing. What does absolute value do? What's absolute value of -3? 3, right? In other words, if you're draw that line a little better. If this is 0 and this is -3. And what's absolute value of regular 3? 3. It's also 3. In other words, absolute value always tells you how long you are, right? A vector going from here to here or a vector going from there to there. We don't care. Either way, its length is 3, right? Absolute value just gives you how long you are. It doesn't care about the direction, negative, positive, whatever, right? Isn't that what absolute value does? That's exactly what absolute value does for vectors. It just gives you the length, the magnitude, whatever you want to call it, nothing to do with the direction. So that's it. So let's go, let me write that out, and then we'll figure that out. So yeah, so you guys are right on. So that means the magnitude or length of the arrow. How long is the arrow? Length of the vector u. So the length of the arrow, the magnitude of the vector, that's what it means. The double bars around a vector mean how long is this thing? I don't care what direction it goes in. You know, we're just ignoring the direction for now. How long is that vector? Well, how are we going to figure that out? Like, how long is vector u? Here, I'm going to go blow up the picture, if that's okay. Okay, so we want to figure out the magnitude, the length of vector u, the top one there. They look like they're the same anyway. But how do you figure out how long it is? Vector u starts up here. You know, they have a direction, obviously. It's an arrow. So how long is it? How can I figure that out? Any ideas?
Could you make
Kevin?
it into a triangle?
I think that's a fabulous idea because you guys are pros at triangles. You know all about it. Like I said, I gave you the grand poobah. You're an official master of triangles, and you are. I'm glad you're showing that that is true. Exactly. What kind of a triangle?
Right triangle.
Of course. Those are our favorite kind. We spent the majority of the course until those last two sections, right? Law of sines, law of cosines. Everything before that was right triangles. You guys are right on the money. You make a little right triangle, and then what? Can we figure out how long that top is?
Yeah.
Just count them. Was it 1, 2, 3, 4, 5, 6, 7? And decide 1, 2, 3, 4, 5, 6, 7, 8. 7 by 8. And so how do I figure out the length, bless you, of the u vector? The Pythagorean Theorem. I knew you would know. Yeah. So it's going to be, so basically, 7 squared plus 8 squared is going to be the magnitude of u squared. Now, I'm fine. I'm not that picky about notation. Honestly, I'm pretty casual about it. But it technically would be wrong. One of your other math teachers might be a little upset with you if you wrote that. That's not technically true. What you have to actually put the bars on it. Why? Why? Well, because u itself is not just a number, remember. That's a little weird to get used to, I know. Because you're kind of used to, like, anytime you see a letter, that's just a variable. It represents a number. Well, when that letter is a vector, it's more than a number, right? It's a number and a direction. So what would it mean to square a direction? I don't even know. So that's not what you really, that's why that's technically not right. I know what you mean. I'm fine if you write that on the test. But I just want to let you know, in higher math, you might have a teacher that goes, unhappy face there. Because, and I want you to know why. And that is because that's not technically a number. U is not just a number. Let me say it that way. He's a direction and a number. So you're saying I'm squaring a direction, which is like, what's that? So really, how you should do it is that. Now that's a number, because that's just the length. No longer direction, and square that. Does that make sense? See the difference? I'm fine if you want to just write u squared. But that's more technically true, because when you put the bars on it, now you've made it just a number, right? You said just its length, and that's what we really mean. Okay, so anyway, let's just work that thing. Well, then how would we solve for the magnitude there? What would I do? What do I need to get rid of that 2 power? Root, huh? And plus or minus, but we're not going to say a negative length. So forget about the plus or minus. So the magnitude of u then, right, because these guys will cancel. So that's just magnitude of u is the square root of 7 squared plus 8 squared. Just work that out. What is that? 49 plus, I was going to say 56. It's not 56. That's 7 times 8. 64. Is that what it is? 130? 113. 113. Square root of 113. That's the length of u. I think they just want you to leave it that way, no decimal, I think. I'll go back and look. Does that make sense? That's how long this is, the square root of 113, whatever number that is. Are we good? Does that make sense? So we'll come up with a general formula then. How do you find the length of any vector? It's the square root of the other two sides squared, huh? So yeah, let me write out a general formula. If you got that one down, I'll say, okay, so the magnitude of any vector, so yeah, let's write a general principle. So if you have a vector u, and here's how they write it in general. Oh yeah, no, that wouldn't make any sense for you right now. I was going to say something. Let's just leave it at that for now. I'll write out a formula once you've got a little more tools. Try v. Well, isn't v the same? Let me look close. I think it's the same. Let me just draw the thing. 1, 2, 3, 4, 5, 6, 7, 8. Goes down 8. 1, 2, 3, 4, 5, 6. Yeah, it's totally the same, huh? It doesn't, it's the same thing. Hey, and does it matter that I have negatives? Down 8, back 7?
No.
No. Because you're going to square them anyway, so we won't bother. It'd be the same exact answer, right? Magnitude of v, that's a v, is the same. Yeah, let's move on to something new. All right, oh yeah, look at question C then. Can you see C? Is u equal to v? Are the vectors the same? Yes, but not just because they both are square root of 113. I hope you know, but maybe you wouldn't. I know you're just getting used to these. So, yes, they are, but it's not just because the square root of 113 equals the square root of 113. That's part of it. Why am I saying that's part of it and that's not the whole thing? Because what is a vector? Remember the movie. I am vector. I am two things. Direction and magnitude. So he's not just his length. Well, yeah, they have the same length, but if they're going to be truly equal, they got to have not only the same length, but also the same direction. And, of course, they are. They're parallel. So it's for both those reasons, huh? They are the same length, and they're the same direction. Because you could have a vector that goes off like this that's the same length, but it's headed in a different direction. Then they would not be equal vectors. They would not be same vectors, would they? On that. Kevin?
What happened if the arrow was pointing the opposite way on one of them?
Yeah, good question. That'd be different, too. Yeah, let me draw that. Yeah, like if you had it starting here and going back there. And that would be vector, whatever, W or whatever. Yeah, that'd be different vector, even though it's the same length and sort of the same direction, but really it's 180 degrees, excuse me, opposite direction. Yeah, good question. Any other questions, please? Throw them out there. We're just getting going on this, yeah.
Option B says no because vectors have the same magnitude and same direction.
Say that again.
On B, or
Uh-oh, do I have the wrong answer?
No. It says no because vectors have the same magnitude and same direction.
Yeah, that's a silly answer.
Oh, okay.
Yeah, they're just giving you a crazy answer.
Yeah, they're just trying to.
They're saying, no, they're not the same because vectors have the same magnitude and direction. Well, they're giving the valid reason. Vectors...
B and C say the same thing. It's just one says one.
Yeah, they should say yes because the vectors have the same... Yeah, they're just being goofy. Yeah.
C and D were just...
They're just the same but the wrong number.
Same but opposite.
Yeah, the same but opposite, yes. Yeah, good, all right.
It would be D, right?
Oh, is it? Maybe I did. Because vectors have the same magnitude. Oh, yeah, I didn't notice we're different. Yeah, no, you're right. Whoops.
Oh, yeah.
Good eye, Kevin. We're all just like, yeah.
Well, yeah.
Yeah, thanks, Kevin. Yeah, same magnitude, same direction. Yes, it is.
Make sure you read it.
Yeah, read all the fine print in the contract. Vector V. Oh, yeah, so here comes the lingo I wanted to show you. 4I plus 3J. 4I plus 3J. Now, what's the IJ thing? It's just X and Y, basically. That's what it is. So when they say 4I plus 3J, what they mean is, let me see if I can do it right over here. They mean start at the origin. Really, you can start anywhere, but to make things simple, we'll start at the origin. Remember, vectors can be moved around. So anyway, yeah, the I is just your X, and the J is your Y. They just make up new letters, which are basically X and Y, but they use, in the vector world, they use I and J. So that means 4 to the right, 3 up. There it is, vector 4i plus 3j. That's 4 right, 1, 2, 3, 4, and 1, 2, 3 up. 4 right and 3 up. That looks like B to me, right? B to me. And then they want the magnitude. See down here, they got the double bars on the V. They even say the word magnitude. Can you figure that out real quick? Find the magnitude, which means the length of vector V there.
5, right? Because it's 3, 4, 5.
Mm-hmm.
All right, yeah, you got it. Good. Good observation. Yeah, it's a 3, 4, 5 triangle, huh? You guys are triangle pros. So yeah, so if you just draw a little triangle here, boom, boom, that's going to be over 4, up 3, right angle. This is x right there, or, magnitude of v, whatever you want to call it. I'll just put magnitude of v. So anyway, yeah, magnitude of v, I'll just write it formally, but you're right, is the square root. So what we see is the square root of 3 squared plus 4 squared, or vice versa. So the magnitude of v is the square root of 25. Magnitude of v is 5. Magnitude of v is 5. The length of v is 5. We good on that? So now I can give you a formal definition. What's the magnitude of any vector? It's the square root of the x component squared plus the y component squared. Right? Or the I and the j, whatever you want to call them. X and y, I and j, whatever. It's the sideways number and the up-down number squared and added, because it's the Pythagorean Theorem, as we've seen. Huh? Is that good? That making sense? The length of a vector? What's that?
Do you think we'll need that on our 2 by 5?
Yeah, I mean, yeah, it's up to you, unless you just feel like you can just remember it. Yeah, whatever you can't remember, put on there. All right, so minus 8i minus 4j. So yeah, let me just write it a little bigger. Number 3. So v is minus 8i minus 4j.
Yeah, you kind of think of those as sine and cosine. So you got
Yeah.
a negative sine and a negative cosine, so it's going to be quadrant 3.
Yeah, right, yeah. Because we know that x stuff is cosine, the y stuff is sine. Yeah, that's right, yeah. Yeah, go ahead and, so it's going to be quadrant 3 for sure. Yeah. So draw that starting from the origin there. Yeah, like Wendy's saying. It's going to be, so the I is the sideways, which is always cosine, huh? It's going to be the sideways. So it's going to be back 8. 1, 2, 3, 4, 5, 6, 7, 8. And then down, because negative is down, 4, 1, 2, 3, 4. Like that. So back 8, down 4. Is that making sense there? Is that good? So now, so there it is, and so notice it's an arrow, right? So it always has like a starting point and an ending point, an ending arrow, like that. So that's the vector. Back 8, down 4. And do they want the magnitude? They do. So can you find the magnitude? So find the magnitude, the length of that vector v there. It's vector v. So find his magnitude. So the magnitude of vector v is going to be the square root of negative 8 squared plus negative 4 squared. So magnitude of vector v is 64 plus 16, which is, what is that, 80? 80? Just 80, huh? It's just 80. Oh, and then we can simplify that, huh? What do they want? Type an exact answer, use radicals. Yeah, so we have to simplify that square root of 80. Let's do that. 8 times 10, and just break that down. So that's 2 times 4, 2 times 5. The 4 breaks down 2 times 2. Okay, so you remember how to simplify square roots from your algebra days? I'm glad to go slowly over that and review that with you. So you do break the 80 all the way down. We've done a little bit of that in here, haven't we? A little bit, that's right. So you've seen it. So I'll bring it over here. So so then what do we got? 1, 2, 3, 4 2s and a 5. 1, 2, 3, 4 2s and a 5. 4 2s and a 5. And so what comes out? Yeah. These two 2s send out a 2. They're gone. Remember, it's 2 for 1 deal. Square roots are a 2 for 1 deal. 2 in, 1 out. You with me? Because the square root of 9 is 3, for example, right? And think about what just happened there. What is 9? 2 3s multiplied, right? 3 times 3. So see how square roots always take 2 whatevers inside and send one of them outside, don't they? That's just what square roots always do. So therefore, that's what will happen here. These two 2s send out a 2. They're gone. So they multiply when they come out, just like they were on the inside. So that's 4. What's left on the inside? Root 5. So 4 root 5. 4 square root 5. And there we go. So that's the length of that vector. 4 square root 5. Questions on that? Is that making sense? We good? So they want me to say vector v find the vector from P1 to P2. So vector v from P1 to P2. So let's put that on the graph there. Let's find this point. Oh, I didn't leave enough room to find that point. It's going to be a hard one to find. Here, I'm going to need a little more room in this axis system I made. I need to go down 9. So more like that. Okay. So back to down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Back to down 9 and over 3. 1, 2, 3, up 6. 2, 3, 4, 5, 6. So there's point 2, which is 3, 6. And here's point 1, negative 2, 9. So we're talking about the vector that goes from P1 to P2. So I'll make an arrow like that. It's a pretty straight vector for me. All right. Like that. And so now what they're asking, you might wonder, what do they even want? So this is the vector v. They want me to write it in terms of I and j. So they want me to write vector v is, let's just call it ai plus bj. Or x if you want. How about xi, whatever. It doesn't really matter, but maybe x would make more sense. So, some amount over, some amount up. So what are we going to do? We're going to make a triangle. This has been trigonometry, yeah. So these things we're learning are obviously related to triangles. They're a natural extension of triangles. And it's, of course, a right triangle, the kind we spent 90% of our time learning. All right, so basically we're going to make a right triangle, and we're going to say vector v. So these vectors are always the hypotenuse of a right triangle. You see in the pattern? That'll always be the pattern. That's always how vectors are. I was doing physics with my daughter, same thing. The vectors, we make them the hypotenuse of right triangles, what we always do. Okay, so that vector v is how far sideways, how far up and down. Now we can try to count, but what if they make them real big? We're not going to want to count all the time. Is there a way we could get it with more easily? I don't know if it'd be easier this one.
Yeah,
Yeah. So here you would subtract the 2 x values, and here you would subtract the 2 y values. Does that make sense? Because the difference in their heights gives you the total height, and the difference in their x values, right? So this one's back here at -2. This one's over at +3. So that's, the x1, y1, x2, y2. Wendy?
Should it be absolute values of x2 minus x1?
Absolute value of x2.
Or
X2, those are just numbers. So those are okay, those aren't vectors. So x1 and x2 are just numbers. So I can just subtract them like numbers. So they're not vectors. The only letter that really is a vector here is the V. So he's the only one I'd have to be super careful with. Everything else it just represents numbers on that. So then how we can actually do this? So vector V would be the difference in x values times I plus the difference in y values times j. Like that. You guys tracking with me? Is this making sense? So the difference in x values is how wide, and the difference in y values is how far up. Now, so you don't have to draw the picture. Does that make sense? I was just doing that to give you more of a feel. But on an actual homework problem, you probably wouldn't draw the picture. You would just look at the x and y values. So this is, whoops, I made a big thing there. I don't know why it's doing that. There we go. So x1, y1, x2, y2. So, all right, so here we go. So vector V is the difference in x values. So that'd be 3 minus -2. 3 minus -2i plus 6 minus -9. J. And so vector V. So what is 3 minus -2? Yeah, it's going to add, huh? The two negatives are going to add. 3 plus 2, 5i. And the two negatives are going to add, what's that, 15? 15j. So it's 5 to the right, 15 up. There is vector V, which has both direction and magnitude. It's 5 to the right and 15 up. And that's all they want. They don't want the magnitude. They don't want the length. So we stop right there. So that's vector V. It's the vector that goes 5 right and 15 up. From here, if you go 5 right and 15 up, that's vector V. Make sense on that? So the I is the right amount, the J is the up. The I is like the X, the J is the Y. All right. So number 5 is P1 is -6,5. And P2 is -8, -3. Like that. And they want us to find vector V, which is from P1 to P2. So find vector V from P1 to P2. Okay, can you do that? Can you find vector V from P1 to P2? Same way we just did it. You don't have to draw a picture or anything. So vector V, let me just write out the formula. In other words, it's going to, what am I doing? It's not square root. We're not doing the magnitude. We're just doing the vector. So x2 minus x1 I plus y2 minus y1 j. So difference in x values I, difference in y values j. Like that. See if you can figure that out from there. Give you a second. Okay, so this is x1, y1, x2, y2. All right, so let's give this a try here. So here is x2 minus x1 minus 8 minus 6. I, good so far, plus y2, bless you, minus y1, j. So difference of x values I, difference of y values j. So what is that? Those two negatives right there become positive. So negative 8 plus 6, negative 2. You don't need parentheses. I don't know why I have them, whatever. Negative 8, j. Yeah, you don't need parentheses, so it's just minus 2i minus 8j in the end. You could write plus a negative or just negative. It doesn't matter. Does that make sense on that? Vector v? You get so what does that mean? You don't have to draw a picture or anything, but I just want to show you. That means that's the vector. If you started at the origin, remember you can start anywhere. It would go back to down 8. 1, 2, 3, 4, 5, 6, 7, 8. So it'd go back to down 8. There's vector v. And you can move it anywhere. You can move it over here. And it would still be the vector that's back to down 8. You know, moved anywhere. It doesn't matter where they sit, but they go back to down 8, wherever they sit. Direction and magnitude. Good? Okay. So try that. See if you can add those two vectors together. Oh, so I didn't even tell you how to do it, but I'm just assuming you naturally know. So how do you think you would add those vectors together? Yeah, like terms. Exactly. I knew you would know. Yeah, just add the I stuff with the I stuff and the J stuff with the J stuff. Exactly. Yeah. So when we add those up, we just go, okay, 5i and minus 6i, negative I, and minus 3j plus 8j, plus 5j. And we're done. Really natural. Why don't we just subtract them right now? Let's just do number 6, even though they don't ask us to. How about we subtract? So I'm just going to pretend that they put it, because I don't want to rewrite number 7, da-da-da. Let's just do it right there under. So how would you subtract those two vectors? Yeah, it's the same thing. But you'd have to be careful to distribute the minus sign. That's all I want to make sure you're good with, right? So you'd have to go, okay, vector u first, which is 5i minus 3j, minus vector v, which is minus 6i plus 8j. Like that. So u minus v, like that. And then you know what to do with a minus sign in front of parentheses. It just distributes, and then it's the same, huh? So that would be 5i minus 3j plus 6i minus 8j, right? Which is 5i plus 6i. 11i minus 3i minus 8j. What's that? Minus 11j, huh? 11i minus 11j? Good? So, subtracting, just what you'd expect. Just remember to distribute, and it's all good. So try that one. They want you to take 4 times vector v, subtract 8 times vector w, and combine all the like terms. So give that a try. So 4 times vector v. So I'm just going to write it there. Minus 5i plus 4j minus 8 times vector w. So there's vector v. There's vector w. Good so far. And then just distribute and combine like terms, right? So what do we get? Boom, boom. So I'm going to get minus 20i plus 16j. Boom, boom. Plus 8i plus 48j. Negative times negative. Good so far? And then just combine minus 20i and plus 8i. Minus 12i. 16j and 48j. What's that, 64? Positive 64j. And there we go. Easy enough? So just multiplying vectors and adding or multiplying constants times vectors and then adding vectors and subtracting vectors. But you see what we're doing? We're in a whole new world here. And so in this world of vectors, they're defining the rules. So whenever you remember, all of math is made up, right? I've said that a few times, haven't I? This is just made up. There's no such thing as a vector in the real world, even though there's the movie with the guy who calls himself Vector. There's no such thing. A vector is not a real thing. You can't taste, touch, or smell it. It's not a real thing. It's made up to describe things that are real. That's why they make up all of math, right? To help us with things. There's all kinds of things in physics where vectors are very, very helpful for real life things happening. My point is, though, when they make up something new in math, like they've made up vectors now, which are going to help us do things in the real world, when they make something new up, then they got to make up the rules for those things. That's what we're doing right now. We're saying, okay, we've made up these new things called vectors, which have how far over, call it I, and how far up, call it j. And now we're learning how do you add these things, subtract these things. We're going to get into multiplying these things, dividing these things. What are all the rules for dealing with these new creations called vectors? That's what we're doing. All right, so try that. So they're giving me here vector u, 2i minus 8j, and vector w, minus I, which means 1i, minus 5j. And then they want the magnitude. All right, see the double bars? Double bars, the magnitude, the length of w minus u. So you know what you need to do? You've got to first find w minus u. Don't worry about the magnitude stuff. Just first find the new vector made out of the other two vectors, w minus u. So find that, and once you've got that, then second, do the magnitude of that thing. So first, find the vector, then do the magnitude of that vector. Let's give it a try. So w minus u would be the w vector, which is minus I minus 5j, minus the u vector, which is 2i minus 8j. Okay, so we distribute that minus sign. So minus I minus 5j minus 2i plus 8j. So minus I minus 2i is minus 3i. And minus 5j plus 8j is plus 3j. There we go. Oh, wait, no, we're not done. There we go, halfway. So now that's the vector w minus u. Now we've got to find the magnitude of it, right? So now we say, okay, Now the magnitude of w minus u, this is w minus 2, so it's the magnitude of the minus 3I plus 3j, bless you, which is the square root of the x squared, or the I squared, whatever you want to call it, plus the square root of the x squared plus y squared. So there we go. So that's going to be square root of 9 plus 9, square root of 18. We good to there so far? So square root of 18, if you break it down, is 2 times 9, which is 2 times 3 times 3, right? And so those 2 3's send out a 3. Yep, Kevin's got it. 3 root 2. That's the magnitude of w minus u. We good with all those steps? Is that making good sense? All right. Okay, so they're going to say here, find a vector. Now, how do they say it? Find the unit vector in the same direction, yeah. Okay, find a unit vector in the same direction as v. It's supposed to be v there. Find a unit vector in the same direction as v. Let me draw this out. Not required, but I think I want to really sink it in your mind what we're even talking about here. So let me actually draw this one. So this vector is back 8 down. Oh, so it's back and down. It's third quadrant, huh? So it should be like that. Okay. So I'm going to go from the origin, back 8 down 6. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So back 8, down 6, like that. So there's the vector v, right? He goes back 8, down 6. Back 8, down 6. We're good there? So that's vector v. Now, what do they want me to do? They want me to find a unit vector. Now, what have we learned unit means? The unit circle. Remember, what's the radius of the unit circle? The radius is the distance from the middle to the edge. 1. Unit means 1. Unit means 1. Yeah, so so when they say unit circle or unit vector, they mean length 1, radius 1. So they want me to find a unit vector, meaning a vector, unit vector. Unit means length equal to 1. Unit means length equal to 1. So they want me to find a vector of length 1 that goes in the same direction as v. So in other words, they want like a little tiny one right there. Does that make sense? I want to give you, no picture required, but I think it'll stick better with you if I show you. That's what we're trying to find. A little vector that heads off in the same direction, along the same line as v, but it's tiny. It's only of length 1. Those become super useful in higher math, like I said, Calc 3, because a lot of times you care about the direction something in, but then you do something else for the length. So you just want the little unit vector. Comes up a lot. So how do we do it? Any ideas? So basically we got to strip out the length somehow. We got to keep the direction, but make its length only 1, huh? That's the game plan. Somehow take the vector that you've got right here, keep that direction, that back 8, down 6 sort of heading, but make its length only 1. What's its current length? How about that? Can we find how long the current vector is? Like, what is the magnitude of vector, the length of current? It's not 1, huh? It's way longer than 1. What is it? What's the formula for finding the magnitude? The hypotenuse of a right triangle, basically, right? You're saying, back 8, down 6, right triangle, how long is v, right? So it's the square root of x squared plus y squared, right? Negative 8 squared plus negative 6 squared. Like that. Square root of x squared plus y squared. That's the magnitude of vector v. And so what's that? 64 plus 36, square root of 110. So the magnitude of vector v is 10. The length of vector v is 10. Okay, great. So what? So right now, this thing's magnitude is 10. From there to there is 10. I want to shrink it down to have only a length of 1. So what if I have a number like, what if you have a number and you want to make it 1? What if I had 18 and I said, I want to make that 1? What would I do? I would divide by 18. What if I had 29 and said, I want to make that 1? I would divide by 29. So in other words, the way you make something 1 is you divide by what it is. Right? Does that make sense? So if I take the original vector v, let me bring it down here for us. The original vector v, which is minus 8i minus 6j, and I divide by its length, both the components, so divide by 10 and divide by 10, that'll make its length 1, won't it? So you take v and you divide by the magnitude of v. Does that make sense? That's how you do it. That's how you make a unit vector. You take the original and you divide by how long it is, because that'll shrink it without changing the direction. Make sense on that? So then what do you get from that? I don't know. That'll be, just simplify that. Divide by 2. Top and bottom, minus 4/5 I. Same thing here. Divide by 2. Minus 3/5 j. There we go. That's the unit vector. That's a vector headed in the same direction as the original, but its length is only 1. How do we know? Because we divided it by its own length. So that makes its length only 1. But it's still headed in the same direction because we used the original vector for the heading. Is that good? Comes up a lot in higher math if you're going there. So no picture required. So let me write out the general formula then for finding a unit vector. Maybe I'll put it in over here. So a unit vector is always v over the magnitude of v. That's how you find a unit vector. Take any vector and divide it by its length, its magnitude, and you'll have it. You'll turn it into a unit vector. Length of 1 headed in the same direction. All right, I'll move on if you're good. Let me know. Okay, try that one. Yeah.
What am I looking for?
Oh, find the unit vector. Find the unit vector. Find the unit vector. So it's v over the magnitude of v, so we got to find the magnitude of v first, don't we? So the unit vector equals v over the magnitude of V. So that's going to be I plus 5j divided by, and what's the magnitude? It's the square root. Now what's the first number?
1.
There's an understood 1 there, huh? Visible 1. Square root of 1 squared plus 5 squared. Which is 1i plus 5j, both over the square root of 26. We okay with that? That's just 1 plus 25. Good to there so far.
So what do you do? Because you can't have a root in the bottom, right?
Good, yeah. Right on. Good, Kevin. Yeah, we can't have a root in the bottom, so what do we do? Top and bottom by that root, huh? Yeah, we can't leave it this way because we never leave roots in the bottom. So we just multiply top and bottom of both of them by root 26. You guys okay? I put that root underneath each of them, right? Because it separates to be underneath both of them. And then we multiply top and bottom for both. And so what do we get there? Here, 1 times root 26 is just root 26. What's root 26 times root 26? Plain 26. Yeah, we okay with that? Remember, 2 for 1 deal, huh? 2 for 1. So 2 26s in a root is 1 26 out of the root. I plus, and over here, 5 root 26. The bottom, root 26 is plain 26j. There we go. That's the unit vector. That's a vector of length 1 in the same direction. Because we took the original and we divided by its length. So when you divide by the length, it's only 1 now. Length of 1. Good? It's making sense? Making unit vectors? All right. So they want us to take this, and they want you to write vector v in terms of I and j. So in other words, they want like 2i plus 3j or something, you know. So they're what are they doing here? So let me draw again. Picture not required, but I'm going to give you a picture just to show you. Then, in fact, how about I just give you the formula? We crank out the problem, and after all is said and done, I'll draw a picture to show you why it's true. So here's what you do. So basically, you just take the magnitude they gave you, because that's the length, huh? Times the cosine of the angle I plus the magnitude of the vector sine of the angle j. There's the form. There's the golden ticket. That's how you go from angle direction to ij. We're going to do that a lot. We'll keep doing that through even in this course. Get you more and more comfortable with that. And that's always how it is, math, because you guys said you're going to take physics, and it's always tricky to apply math. You know what I mean? Because you kind of learn math. It's kind of like, there it is. I remember my daughter saying that because she started physics this semester, and I was helping her. And the very first thing they did was vectors. And she's like, it's like I learned the math, Dad, but like when they put this word problem thing there, which is all physics is all word problems, it's like, wait, how does the math work in this setting? It's tricky. You got to really know the vectors deeper. Then I would show her, see, remember what you learned about vectors? See, this is a vector. When they say these words, that means this, right? She's like, oh, yeah. But I couldn't see it when I just read those words. So that's what's tricky. So you want to learn the math well because it's harder in physics when there's word problems. That's just how it works. So all right. So there's the formula. So let's just crank it out, and then I'll show you where'd that formula come from. Like, why is that true? I don't like giving formulas like it's magic, because it's not magic. But anyway, let's just crank it out. So magnitude of V, I got to get that first. Oh, no, they gave me that. That's 8. So that's 8 cosine of 315 I plus 8 sine of 315 j. Okay, and then, there's my calculator. So let's crank that out. Make sure you're in degree mode. You could just go to the unit circle too. Do they want to? Let's go to 315. I'm gonna draw a little unit circle here. Where's 315? This is 270, 360. Is it right in the middle?
Yeah, it's 45.
Yeah, it's right there, huh? It's like 45 degrees. Yes. So 315 is right there. So that means, remember the small, medium, large, all that? So that's over medium, down medium, huh? That's over root 2 over 2, down root 2 over 2. You with me? Remember all that for the unit circle? Right and down, so it's positive, negative. So this is cosine is always the x, sine is always the y. Okay, so there we go. So now we're rolling. So this will be 8 times cosine, root 2 over 2i, plus 8 times sine. Sine is negative root 2 over 2j. Can we simplify that? Let me get this out of the way a little bit so we can work with it here. So that would be 8. So how do you simplify? We all good to hear so far? How do you simplify a whole number 8 times a fraction? What do you always do? Over 1, cross cancel, huh? Remember the whole thing? Put this over 1. 2 goes into 8 4 times. So this would be 4 root 2i. That's supposed to be an I there. 4 root 2i plus 8 over 1. 2 goes into 8 4 times. Oh, minus. Going to be minus, huh? Minus 4 root 2j. There it is. 4 root 2i minus 4 root 2j. That's vector v. Now, why in the world does that formula work? I'll show you. First off, do you feel the truth of that, though? Like, what if you were to find that? Where is that? 4 root 2 is just some number, whatever. But my point is it's right and it's down. You with me? This is positive and this is negative. So it's positive 4 root 2 and then negative 4 root 2. So the vector is like that, isn't it? It's right and down. And that makes sense. 315 degrees. And what they're saying is the length is 8 at an angle of 315 degrees. So if you start at 0, turn all the way to 300, it's like a cannon. You turn the cannon to 315 degrees and you fire out a distance of 8. So we did the same thing with I and j. 4 root 2 right, 4 root 2 down. Same direction for sure. Is the length 8? Yeah, you could find it, actually. If you found the length of that, let me do it real quick. Not required, but if you took 4 root 2 squared, remember how to find the length, square root of the x squared plus y squared, plus 4 root 2 squared. What's 4 root 2 squared? What's 4 squared? 16. What's root 2 squared? 2. Plain 2, right? Removes the root. Plus 16 times 2. 32 plus 32. Root of 64 is 8. Same. See how his length is 8? You know, that's all not required. I'm just proving it's right. It's true. What we found is the same length, same direction. Same magnitude, right? Because I just, maybe I went too quick there, but I just squared the 4, 16, removed the root. 16 times 2 is 32 plus 32. 64 is 8. So that means his length is 8, and sure enough, he's headed in the right direction. Lower right corner, right and down. Yeah, that's the same vector, isn't it? That is a vector of length 8 headed in the direction 315. So we just translated from angle and direction to ij. We're going to do that all the time. We're back and forth. Now, why does that little formula work? Why does cosine and sine, this made-up weird trig thing that we learned earlier, work? Now, here we have well, it isn't quite real life yet. But soon, if I get moving. Anyway, why does that work? Let me show you why that formula is right. Very important. You're going to want to remember that. We'll put it on your 3x5 card for sure. So yeah, why does it work? It's because that when you're at a certain angle, let me just do one in the first quadrant. It's just easier to look at first quadrant, but it's the same thing in any quadrant. If I was to say I've got some vector v here, let me do that in red so it's more clear. I got vector v right here, vector v. Okay, and I want to know how far to the right and how far up. X, I, and Y, J. Let's just call it X and Y, whatever. I and J, whatever you want to call it. You know, how far over, how far up. That's what we're looking to do, right? They're giving me some kind of vector, and it's headed at some angle theta, and I want to change it to X, Y, I, J, same thing. That's what we're basically doing. How would you do that? Well, can you see that it's a right triangle? Of course you can. It's straight over, straight up. And how would you find these sides? Well, remember the SOHCAHTOA, right? In a right triangle, you can always use SOHCAHTOA. So if I start with cosine, what's cosine of theta going to be? I'm just proving that formula's right. Cosine, this is adjacent side, this is opposite, this is hypotenuse. So cosine would be adjacent, which is x over magnitude of v. Right? And this is vector v, but maybe I should put, magnitude of v, length of v, right? So cosine of theta would be adjacent over hypotenuse. So how do you solve there for x? How do you get x alone? Why do we want x? Because x is how far to the right. Y is how far up and down. Right? How do you solve for x? Put this over 1. Diagonal, diagonal. So magnitude of v, cos theta is 1 times x, or just x. So what does x equal? How far to the right? V cos theta. Which is exactly what we have here. V cos theta, magnitude of v cos theta. See how that's true? That's all it comes from. It's just a little simple right triangle. Same thing over here for y. If you did the sine. Sine of theta, do sine, it's opposite over hypotenuse. Y over magnitude of v, same thing you can see. Y is going to be magnitude of v sine theta. And it makes sense, doesn't it? What have we learned all along about cosine? What's cosine always? Sideways. What's sine always? Up, down. So no surprise, cosine is with the I, sideways. And sine is with the J, up, down. Always. So that'll become very useful, especially if you're going to physics. I've been this very semester working with my daughter, and they'll have these boxes sitting on ramps, and they'll have these little pulleys, and they're pulling things, and they'll say its weight goes straight down, and they'll say, what's the component of the weight headed down the ramp? And that always has to do with trigonometry and vectors and these exact same thing we're dealing with right here. So 17 says a vector is described, make it I and J. Quarterback releases the football with a speed of 40 feet per second, angle of 60 degrees with the horizontal. So let me write out what that's saying. Whoops, I hit the button there. So it's an angle, speed of 40, angle 60 degrees. So the quarterback throws it like this. It's at an angle of 60 degrees. 40 is the speed vector. It's the magnitude of the speed vector. 40, feet per second at an angle of 60 degrees. So basically it's just a vector. To say the quarterback releases the ball, and 40 is the speed vector at an angle of 60 degrees. And they're saying, make that I and J. Make vector V. Make V into I and J. All right, so go ahead. So just do the same thing we just did, right? Use that exact same formula. Vector V will be the magnitude of it times the cosine of theta I plus the magnitude of it sine theta J. I didn't notice here. What does it say? Nope. Exact answer. Radicals is needed. No calculator. Let's try that one. See if you can get that. So we're doing okay. So what's the magnitude? That's the 40, right? We good with that? So that's the 40. Cosine of 60 degrees I plus 40 sine 60 degrees j. Okay, so if you go to the unit circle, go over here real quick. 60-degree angle. So, which is right there, right, almost to 90. So we remember that's over a little bit, up a lot, right? That's over a half, up 3/2. So that's cosine sine from the unit circle. So vector v is 40 times the cos of 60, which is a half, I plus 40 sine of 60, 3/2j. Okay, so half of 40, 20, I, right? And then here, same thing, 2 goes into 40, 20 times be 20√3j. We good? That's the ij vector. Are we good? Questions on that one? Now, so what? What does that mean in the real world? Well, what is that vector? Remember the quarterback threw the football at 40 feet per second at an angle of 60 degrees, kind of up and to the right, huh? Angle of 60 degrees, 40 feet, what's feet per second. Right. So what's this 20i, 20√3j have to do with the real world and that football and that field and real life? Because otherwise, let's quit. What are we even doing here, right? What does this mean? I love the real life application. So what does this mean? What do you think that 20i means?
That's how far it goes distance-wise. And then the other one is for height.
Okay, almost. Yeah, right. You're thinking right. Not far, though. Not far. None of this is distance. All this is speed. Feet per second, right? They could have given us distance, but they gave us speed. So everything we're talking about in this is speed, how fast. So one more time, Kevin, on your statement then. What is that 20?
It's for the speed it travels.
Speed it travels how?
Like across the football.
Exactly. It's the sideways speed. Yeah, Kevin's right on the money. And the 20√3, what is that? That's a number. If you have your calculator, 1.7. I think that's about 1.7, 34, isn't it?
34.60.
Yeah, 34 point whatever. So in other words, that football is traveling sideways at 20 feet per second, because that's the I. The I is sideways. And it's going up at 34. That's the J. 34 feet per second. It's going faster up than it is sideways. Why? Because he threw it at more than 45-degree angle, more than halfway, more than the diagonal. He threw it more up. So at least at release, at time of release, that football is going up 34, that's a 3 there, 34 feet per second, and sideways at 20 feet per second. Now, what's going to happen, we'll do a real smidgen of physics here. What's going to happen is right away, as soon as he releases from his hand, what's going to start affecting that football? Gravity is going to lay hold of that ball and start pulling it down at 9.8 meters per second squared, or 32 feet per second squared, is the gravity, acceleration of gravity, is going to pull on that ball. So we know that ball's height is not going to continue to go up at 34 feet per second, but its sideways will. Did you know that? It will, aside from wind resistance, wind will have a small effect, but not a lot for a football thrown that fast. It won't mainly be wind. It'll go pretty close to 20 feet per second. So what does that mean? Well, if you say, okay, he threw the football for 3 seconds in the air to the receiver, 3 seconds, I can find out real quick how far down the field that ball went. If he threw for 3 seconds, I know it's moving sideways 20 feet every second. So if it traveled for 3 seconds,
60 feet.
Yeah, 20 feet, 20 feet, 20 feet. That ball went 60 feet.
Which is 20 yards.
Which is 20 yards down the field in 3 seconds of throw. Because the sideways tells me how far down the field. That's why it's important to know that, because that's what we'd really care about, right? Anyway, there's just an example of why we care about I and J components and how they affect the other way. So on this one, number 15, they're giving me the IJ There it is. They're giving me the ij, and they want me to change it back into magnitude and angle. Is that making sense? So they want me to go backwards now. So last couple problems, they gave me the angle, right? Football player throws it at 60 degrees, and the magnitude at 40 feet per second. I changed it to ij. Now it's ij backwards. Well, how do you go backwards? How are we going to go backwards? So what do we need? First off, we need magnitude. That you know, right? That we've already. How do we find magnitude? Pythagorean theorem. Square root of a squared plus b squared, right? Square root of negative 8 squared plus 15 squared. And that's what? 64 plus, is that 225?
Yeah, it's going to be 289. And square root of 17.
17 it is. So the length of that vector is 17. So that vector that goes back 8, up 15, has a length of 17. I'm going to go to a fresh screen if you're okay with that. I probably should have from the beginning. Here, let me go. Number 15. So vector v is minus 8i plus 15j. Vector v is the square root of the first one squared plus the second one squared, as we've already learned. Square root of 289, 17. Okay, so that's the length of it. Let's draw it now. Let's draw it. And this kind of is required in this case. You really need to see it. So this will really, it's an essential step. So let's draw the actual vector. So starting from the origin, just because that's convenient, back 8, up 15. So I'm just going to go like that. So it's back 8, up 15. You with me? So there's vector v, back 8, up 15. So it's second quadrant, isn't it? Because it's back and up. Second quadrant. Back 8, up 15. Back 8, up 15. So, and what do they want from me now? What's the other thing they want? Yeah, the angle theta, which is the direction angle, notice. They want the direction angle theta. So what is the direction angle? Direction angle theta. So what do they mean by direction angle? They mean this angle, don't they? Because this is 0. This is 0 degrees, right? So you're always starting from 0. Starting from 0, what angle? Because here's the vector, right? It's headed off in this direction. So what angle is that? What direction angle is that vector? We know how long the vector is. The vector's length is 17. But what's his direction angle? Something more than 90, huh? Less than 180. We can see that much. How are we going to find out exactly what it is? Any ideas?
Can we use the formula for side, side, side?
Side, side, side? To find an angle?
You could just use the angle, and then you could use something like sine or cosine, couldn't you?
Mm-hmm. Yeah, right. Because it is a right triangle, so we can do... Yeah, we could do some fancy log sines, log cosine stuff. But yeah, why don't we just do SOHCAHTOA, since it is a right triangle, to make it as easy as possible. Yeah, I agree. Let's do some SOHCAHTOA stuff, even though Kevin's right on. Log sines and cosines could be used to do this as well. So how about we call this angle in here, I don't know, I want to use theta again, but so I'll call it x, I guess. Not used to x being an angle, but whatever. So I'll just call that angle x. If I can find angle x, then I can, from there, find angle theta, can't I? You with me? So how do we find angle x? What am I going to do to find angle x? Well, there's various, there's various, like I could do sine is opposite over hypotenuse, or I could do cosine is adjacent over, do I know the v? Yeah, it's 17. So since I know the v now is 17, I could actually do any trig relationship, couldn't I? I could do sine, 15 over 17, hit the inverse sine of my calculator, or cosine is negative 8 over 17, hit the inverse cosine of my calculator. But you know what would be easiest? Tangent, because that way, because what if this v is some weird number? You know, now this one came out clean, but they're going to give us harder ones, where it's decimals that go on and on and on, or roots or whatever. And I'm always going to have these numbers because these are the I and the j. They got to give me those. So let's set up a pattern. Now I'm going to deviate from the book a little bit here, though. Show me an example, because yeah. So I think you can do whatever you want. I never care, but I think this will be easiest for you. Just do tangent of theta is now what's tangent or x in this case? X, my little angle x. Tangent of x is, remember what tangent is? Opposite over adjacent, right? Remember, so toa, opposite over adjacent, right? So I'm going to do tangent of angle x is always what? In fact, you know, instead of x, that x is bugging me because it's just, I don't like x for an angle, you know? How about I call it ref? It's the referee. It's the reference angle. It's the reference because it's the angle to the x-axis, huh? So I'm going to say the tangent of the reference angle there. Now to remind me, it's not my final answer either. It's just the reference angle. The tangent of the reference angle. It's the first time I've ever used this notation, but I like it so far. All right, we'll see. I think it might be helpful. Tangent of that reference angle is what? What's the tangent going to be? Opposite over adjacent. But let's make up a general rule here. It's always going to be the j component over the I component, isn't it? Because the j, the op, will always be the opposite, and the I will always be the adjacent. So basically, here's your formula. It's always the j component over the I component. The tangent of the reference angle will always be the j component. I'm going to give you a formula where you don't have to work so hard every time. It's always this game plan. So the reference angle then will be what? What's the reference angle equal to? How do you get that reference angle alone? It's got a tangent on it. Tan inverse. You guys know, being masters of trigonometry. That's right. So yeah, tan inverse, I'm going to write tan inverse on both sides cancels out. So tan inverse of j over I. That's basically the formula we're going to use. The reference angle, whenever, because they're going to do this a lot in sections to come, even in this course, a lot. They're going to give us I and j. They're going to ask us to change it back to magnitude. We already know how to do that. And reference angle. And the reference angle can be a little tricky. How do you do it? Inverse tangent of j over I. That'll be the reference. And then we got to do something else on that. Kevin?
We have to switch back to degree mode, right?
Yeah, right. You want to be in degree mode. You getting an answer there? Tangent, so it's going to be the reference angle. It's going to be tangent inverse of the j. What's the j? 15 over the 8. Oh, yeah. Don't worry about the negative. In fact, don't put in the negative. Yeah, I should have said just put in the absolute values of those. Just 15 over 8. Is that confusing? Why is that? Because I'm treating it as a real triangle here. And I'm not wanting the negative 8. Yeah. So I should say of the positive and the positive. Yeah, that's the formula. So it's the inverse tangent of the positive I and j. So, and I get, what do I get? 61.9, I don't know how far they want to run. 61.93 degrees. Y'all getting that? So just make those positive. Again, why you might wonder why? Why are you making those positive? Because this is just a triangle, real life triangle here, so you can't have a negative length. I'm going to take care of the fact that it's second quadrant in the end. So I will deal with the fact that it's actually back 8. But for now, right now, I'm just saying this is a triangle. This is 8, this is 15. What's the angle? Not thinking about negatives or positives. Just make everything positive. So that angle, this little angle here, is 61.93 degrees. So then what's the theta? How do I get the theta then?
Subtract 180.
Good job. Yeah, remember how we learned to do the different quadrants? Yeah, so that's 180 to here, and then back up 61.1, so that theta is 180 minus 61.93. And let's do it. And you can use the answer button on your calculator. Take 180 minus answer, minus the last answer, 118.07. Or really, for speed, I just subtract the 180 at the back, and I know and then I just reverse the sign of the answer. 118.07. That's the angle. And that makes sense, right? It's more than 90, right? So 118 looks about right. Somewhere between 90 and 180, right? 118 degrees, length 17. We changed from an IJ format to a magnitude, length, and a direction angle, 118 degrees. 118.07. Questions on that? Austin?
Negative 118?
Nope. No, 118 is the angle from here. So negative would be down this way. Remember, we're talking about angles now, not length. This is an angle, not a length. So negative angles are down from the origin. We mean up 118, like that. All right. The other ones are mildly challenging, but 20 is more. Magnitude and direction of two forces acting on an object are 100 pounds south, 75 degrees east, and 80 pounds north, 52 degrees east, respectively. Find the magnitude to the nearest hundredth of a pound and the direction angle to the nearest tenth of a degree of the resultant force. All right, so we're doing a little physics for sure here. So, and then the next one is the same thing. I'm going to be between magnitude direction, two tugboats. Boom and boom. Find the magnitude. Same thing. All right, these are good problems to do. So, number 20. So I'm going to write out 100 pounds south, 75 east. So number 20. So 100 pounds south. What is it? South 75 east. South 75 east. And what's the other one? 80 pounds north 52 east. 80 pounds north 52 degrees east. Okay, that's all we need. So what are we talking about? Are acting on a what? Acting on an object, yeah, whatever. So I'm going to draw an axis system for us. All right, so it's all about these headings again. Remember these? So let's try to do the first one. Okay, so start at the origin. We'll do it all starting at the origin for our convenience. So can you draw south 75 east? So first off, let me let you do that. Do you remember how to do that? Go do that real quick. South 75 east. Do you know how to put that? Give me an arrow starting from the origin that goes south 75 east. Remember, it's north straight up, south, east to the right, west to the left. So give me south 75 east. So, remember how that works? You go straight south at first, because it starts with south, But then it's not straight south, it's 75 to the east of that, Which is almost all the way like that. It's almost 90, right? It's 75, which is almost 90, to the east of south. So here it is. There's the vector. So get rid of that piece. That's not it. Are we good to there so far? So this is the first vector, and that has a length of 100 pounds. So its length is 100. Okay, tracking with me? There's the first vector. It's that away, 100 pounds. Okay, what's the other one? The other one is north 52 east. Can you do that one real quick? North 52 east. So north, that's straight up, but not straight up, 52 to the east of that. So that's just a little past diagonal. And that one's only 80, so that one's actually shorter. This one's 80. The other one's a little longer at 100. There we go. So, and this angle here is 52 off the north, right? So again, those are the two vectors. There's some object right here. This is what you do in physics all the time. You got some object, maybe you got a rope pulling that way and a rope pulling that way. What's going to be the net effect on that object? Clearly, the object is going to be pulled to the right with a lot of pounds of force. But let me ask this. Is it going to be pulled up a little bit or down? What's going to be, because this one's pulling out, that one's pulling down. What's going to be the net effect of those two pulls? Kind of hard to tell, really. I don't know off the top of my head. You can say, well, this one's bigger. Yeah, but he's at a smaller angle. So notice he's not putting much of his downward. Whereas he's smaller, but he's putting more up of what he's got. So I'm not sure. I think the up will probably win, but I'm not sure. So anyway, so how do we figure that out? What's going to be the resultant force? This is what engineers do all the time, is things like this. They figure the forces on walls and blocks and all this. We're getting to some real life stuff here. So how do you do it? What I'm going to present is the idea of making them both into ij vectors and then just adding them up. I think that's exactly what the book does. So let's do that. So I'm going to take this vector first off. To do that, so let me write some steps out here. Number one, find the angles from 0 degrees for both vectors. So first off, find the angles from 0 degrees. Where's 0 degrees? Straight east, huh? That's where they just made 0 that way, right? Way back when we started all this. So then I want to find the angle from 0. So what's that angle right there for the purple vector? And then I got to find the one down here for the black vector as well. So for the purple vector, what angle's he at? It's going to be 90 minus 52,
38.
and that's going to be 38 degrees. You with me so far? He's at 38 degrees. That's his direction angle. Okay, and what's the other one?
15.
Yeah, good. The other one is at 90, not 90 minus 15, 90 minus 75, which is 15. 90 minus 75, which is, nope, I'm sorry. I am sorry. So let me pay attention to what I wrote. I'm not doing so. From 0. Well, you might think, well, that is from 0. Yeah, you could make it negative. It's negative 15 if you want. I think it'd be easier just to go 360 minus whatever. So, or how about it's 270 plus 75? Or 360 minus 15. Am I confusing you by giving too many options? It's 270 plus 75, which is 45. Thank you. Yeah. Now you could do negative 15. That's the same place. But you can't do regular 15. You with me? Regular 15 would be right there. This is regular 15. That's not the direction of that force. He's negative 15 or 345. Either one of those will work. Is this making sense? There is a big difference between positive 15 and negative 15 in which direction, right? So we're getting the actual direction. So when we do this, we're getting the actual direction vector. Y'all with me? So from 0, it's negative 15 or it's 345. I'm just going to go with the 345. So find out the actual direction vectors and then use those. So step 2, use those to find ij for both. Meaning what? It's magnitude of v cosine theta I plus magnitude of the vector sine theta j. You with me? So let's do it for both vectors. So, what's that? Yeah, it's a good idea, maybe. Yeah, let's do that. Let's call this vector v1. And this one down here, vector v2. Good. So vector v1 will be, what's his length, 100? 100 cosine of his angle.
No, it's 2.
Is that 2? Yeah, I kind of reversed them, huh? Sorry, am I confusing you? You want me to call that one 2? I can do that because that was the second one, huh? Yeah. That'd be the first one. So I'm finding the second one is 100 cosine 38 degrees. I plus 100 sine 38 degrees J. Use your calculator. Use quite a bit of accuracy because we're only partway through. Times cosine 38. So I'm getting vector 2 is, I'm going to use like 3 places. 0.801 I and 100 times sine 38. I'm getting 61.566 J. That's vector 2. Let's go back now and find vector 1. Vector 1 is 100. That's his magnitude. Cosine of what angle? 345. I plus 100 sine 345 degrees J.
Why would it be 100? Isn't it only 80?
Yeah, on the first one, it's supposed to be 80 cosine 38, 80 cosine.
Oh, I totally messed it up. Oh my goodness. Yes. Look at that time. I'm messing it all up. All right. Yeah. Sorry, guys. So let's do this. I think we need to look at this a little bit more. So the homework is not going to be due on Wednesday. I encourage you to start on it because both sections will be due on next Monday. So I will need to finish next day. But I'll do a little bit more of this next time.